welcome everyone. So I'm Kartikeya Bola. I'll be the instructor for your pre-conference workshop right from 9:30 to 12:45 p.m. Okay. So on machine learning and data analytics using Orange software. Uh, so probably some of you have not got my communication, but most of you had got some idea about uh, how this particular workshop will be shaped. Right. So the material is nonetheless, the material is all there in the desktop and you can access that. Okay. So let me first tell you about this particular software and why did I take this up particularly? Because there are many here who are analytics aspirants, right? But rather they might be ignoring that just because they are too shy for or they want to refrain from programming. Okay? Because most of the places they say that when it is analytics or data science, you need to know programming. Okay? But I have a different opinion to this because you don't need to do know programming, but you need to know how to develop logic. Okay. And I'm sure most of us have logical minds. Right. So that's where this Orange software is quite useful because it's a visual programming tool. Okay. So unlike where you have to remember any code, here you just have to remember the operations which the different widgets can do. Okay. And more often, whenever we have a analytics work, we work in teams, and naturally we want to have those ideas what we convey or we figure out to others. Okay, so this is also a tool where you can communicate your ideas to some other person. So suppose just like today in the material itself, you could see that there is an Orange worksheet file. Okay, so typically whatever operations we are carrying out, it is in a flow of widgets where the process is conveyed directly. Okay, so you may not be finding it difficult to follow this. Right. So in that sense, this particular software is a very great tool for communicating and applying your logic and leaving the all the mundane programming work to the software. Okay. All that you have to propose is the logic, what has to be done on the data, what way you would like to see this data, right? And obviously, you when it throws some output, you would be in a position to interpret it. Okay. So in this 3 hours and so, of course, I'll be moving right from the basics. So if you see in the material itself, there are 10 folders, okay? And each folder has been given a sequence. So this also enables you and for me both to be in the same page and will be following the same sequence. So the one which is sequenced as number 1, it is the basic part, and slowly we add on the complexity and also move to the higher order techniques. Okay, so 10th being the last one. So even if you see the topic names itself in each of the folders, so you can realize that we are starting right from the structured data and ending up in a unstructured data.
Oh.
I think someone online is very active. All right. So okay, so that's where yeah, from structured data to unstructured data, that's what would be our flow. Now, let's get started with. Okay, my plan is like this. Because we have 10 parts, okay, and we have 3 hours. Okay, so we have to use it to the best possible way. So I will be trying to cover before the coffee break at 11 o'clock, around roughly around 5 to 6, the first 6 portions, and the rest of them follows in the second half. Okay, after the break from 11:15 to 12:45. All right. Now, what I suggest you to do is you can open the material of the first one. Okay. Now, the first part, you see that it's about a data set. Let me first talk about the content which is there inside this folder. So there is a data file called Bollywood.csv. So CSV stands for comma separated value. That means the data has been separated by comma, right? Now, this particular file can be opened in Excel, and you will not feel any difference between an Excel file and this file. Or the only difference what is that a CSV file will be only one sheet file. Okay. So that means you cannot have multiple sheets like in an Excel format. Okay. Now, most often this particular format is used in all of the data management parts. So if you see any of the online tools, or for that matter, any software, they generally accept this CSV format because of the way it stores the data. So it is very compact. And in the era of big data, this really helps to make data as concise as possible. Okay. Now, along with this, of course, for each topic, I have a write-up which you can leisurely take a look at later on. Okay, so I'm not going to discuss that. The one which is there in the, say, like in this case, the EDA and feature construction. So that is a write-up. So you can leisurely have a look at that for your reference. Okay, but now I'm going to just get into problem solving. Okay, so for as an exercise, the first one, so you can open this exploratory data analysis of the Bollywood data set. You can open this. Okay. Now, this is a very familiar data set in sense that it's about the release dates of a movies. Okay. So this is just the metadata of the data. And there are some queries which are made out here. Okay. Like the genre of the movie, the release date, release time, budget. So these are all the variables in the data set of Bollywood.csv. Okay. Now there are some few questions here we are going to address because this is the basic part. So we are going to start from the basic. So there are 6 questions here, like how many records are in the data set. Now, some of them you can answer without even getting into the programming part, right? You can just have a look at the data set. You can say how many records are there, so on. But to understand that in the orange, how you can interpret or where exactly you find that information, we can see that. So how many records are present in the data set, how many movies got released in each genre. So each of these queries, we'll address that in the orange worksheet. Okay, right. So just keep this open. Meanwhile, you can even open the worksheet file. Now, you see this is So .ows format. So OWS stands for Orange Worksheet. Okay. So when you open this, by default, if the Orange software is installed in your system, it will open that directly. Okay. So I'll open this. Yeah, I have already worked it out because you don't have to try too hard, but let's understand the concept and the flow. Okay. Right. Now, let's have a look at the structure in which this comes in and what is the structure which you have in your Orange software. Typically, when you open the Orange interface, on the left-hand side, you see there are different widget groups. We call that as widget groups. Why I say widget groups? Because each one of them which you see here is a widget. Okay. Now, each widget carries out certain operations. So that means there are some inputs to that, and then there are some outputs to that. And the outputs of one widget can be used as inputs to the other widget. Okay. Now, if you look at the left-hand side, you can see that typically when you install it completely new, then you would have around 6 widgets. That is data. There is a data widget. Then there is a transform widget. And then visualization, model, evaluate, okay, unsupervised. So till here, you would be having in any basic format. Now, there are some widget groups which can be installed as an add-on, and that add-on is free. Okay, so don't think that because it's add-on, should we pay for that? So it's completely a free software, right? So, but then it is not added by default. Okay, like for example, the image analytics. Of course, I have added some more for my purpose, but in your system, it would be image analytics and text mining, right? So image analytics and text mining, they are the ones which are add-ons. Like in case when you are going back and working on your system, then to add these add-ons, you have to use the options and then go to add-ons. And please note that when you are doing this activity, you need to be connected to the internet. Okay. Now for today's purpose, we have already added that on, so you need not do this exercise in the class. So now you see, typically the orange would be there by default. Now I have added on image analytics and also text analytics in your system also. So that would be there. Otherwise, you need to check this and then click on OK. Right? And it will take some time to install, and perhaps you may have to open it once again to take that effect. Okay. Right. So this is about the different widgets groups which are there in the system. Okay. Now, depending upon your purpose, you can make use of these widgets. Now, the good part is that they also give you some documentation. So whenever you want to look at a particular widget, so you place that widget in the worksheet. Now, this is the worksheet area. The white space which you see here is the worksheet area. So in this worksheet area, you can place the widget, click on that, then you will see on the left-hand bottom that it will ask, it will give you the description of that particular widget. Okay, and you can click on the link and it will open the documentation, and you can even follow that documentation. It's as simple as that, right? So you need not worry if it's a completely new widget. No, in this particular session, I'll be trying to cover some of the widgets, but most of the widgets or some of the widgets which you have not used it in today's session, perhaps you can even try that and figure out by yourself in the documentation. Okay. Now, so that's about the documentation of the widgets. That's about the different widget groups. Okay. Now let's understand the different widget groups in detail. Okay. Now typically, as the data analytics project, we require a data, right? So we start with the data group widget. Okay. So now you can see in this data group widget, there are different sets of widgets. Like there is a file option, which is the most generic option where you can load an Excel file format, you can load a CSV file format and so on. CSV file import also is there, which typically only takes CSV file format. Now, the difference between these two is that, of course, CSV file is very specialized to CSV format, whereas file also can take up CSV format. But the difference is in file, you can put an Excel format, and perhaps in Excel, you have multiple sheets. So you can even select that particular sheet from where you want to source the data. Okay. Now, so right now, I've already worked out this part. So you can understand, okay, if you can just click on this file. Now, you can always drag the widget. Okay. Let me just show one. Suppose you want to drag the widget, you can drag the widget and place it. Okay. And then you want to load the file, the data source. So then you can double click on this. Okay. And then you pick up just like how you pick up any file from your folder. Okay. So you can see that it's already been loaded in this case. Right. So that's, but you can go back here and then start figuring out where it is located and put. Right. So you can again reload that. Right. So you can pick up this, open this, and then it will open that again. So this is typically how we source the data, right? So already this bollywood.csv has been sourced. Okay. So I'm just deleting this. Yeah. Now, suppose you want to see the contents of that data. Of course, when you open this, you see some of the contents here. Okay. So let's understand these things. Let's understand what is the different variables here, which what it refers to. Now you can see that these are the different variable names in the first thing. So, and you can see there are 149 instances. Then it says 8 features. Data has no target variable and 2 meta attributes. Now this is a concise information about your data. So what does it mean? You have 149 records. Instances means records. 8 features. Okay, now there is a difference between a feature, target, and a meta attribute. Okay. Now, what is a feature? Feature is typically a attribute which describes the record. It is a variable, but then variable becomes a very generic term. So you can say that this is like an independent variable. So if you understand this concept of independent and dependent variable, so independent and dependent variable means that for those who are not that familiar with this terminology, so independent variable basically means what can stay on its own. It doesn't depend on any other column. Okay. Yeah. So that is what we call as independent variable. That means it has not been attributed or it is not been influenced by any other column. Then we call that as a independent variable. Okay.
The instances are it's records.
Yeah, instances are the number of rows or number of records. Independent variables, that is columns.
Okay.
Columns which are not dependent or not influenced by any other variable.
That's a feature.
There are features. Okay. So just to understand in a very notional way. Now you are here because of a workshop, right? So your presence here is dependent upon the workshop being conducted here. Otherwise, you could have been somewhere else. So now this is not a independent variable. Yeah. Yeah, I'm coming to that. Clear? Now, to see the details, you can look at the data table feature. So in a data table, so you can have the data table also here. So you can pull that data table widget and then give a link to that. So you see this link. OK, how do we construct that? Let me tell you this. Suppose I remove this. OK, and now I want the data table. Bring it here. OK, now it requires an input. You can see both sides there is a dotted thing. So that means on the left hand side, it is an input which will go inside this. It will process that and it will show you some output. OK. So if I just take it to here, so whatever I have loaded here as an output, the data, so that would be shown out here. OK. Now, again, you can see that here we have 149 instances, no data. So you can actually check. So you have 149 records. OK, 8 features. OK, no target variable. Now, no target variable because we have not set up any target variable in this case. Later, we'll see that. I'll come to that target variable a bit later because the first 6 parts doesn't require a target variable concept. But target variable basically is a dependent variable. OK, that means sometimes we say that one particular variable depends on the other variables. So we want to set that as a target variable. OK. So target means dependent variable. For time being, let's understand that. And then we'll take it over when we come to that predictive modeling where we say that one depends on the other so that you can predict one based on the other inputs. OK, so typically when it comes to concept of target variable, we use predictions or classifications. OK, right. So for time being, in this case, there is no target variable. So let's go with that. Correct. There are 10 columns. There are 10 columns. And then there are 8 features and 2 meta attributes. Now, why it's called meta attributes? Let me tell you that. Now, meta attributes are those ones where there is, because most often the term variable is misinterpreted. OK, variable actually means varying across different things. OK, and that should be a set pattern. See, when you say gender is a variable, it can have only 2 kinds, right? Male or female. So you can always segregate that as a categorical variable because it mentions male and female categories, right? Now, if suppose a value of one particular variable is different for every record, okay, then it is not very interesting because we never get any patterns, right? So most often the text variables like names, like here we can say movie name. Now movie name is not exactly a variable, right? Because you don't get any sensible information other than the record name. Okay. So most often even in surveys, they generally are not interested in your name. They're interested in your demography, right? Why? Because from demographics, you can at least understand certain patterns. Okay, some people prefer this, some people don't prefer this. Like, but no, the person with this name doesn't prefer this. Nobody will accept that, right? So that's why these type of variables are meta attributes. Most often these attributes. Now, what is the purpose of these attributes? Now, why we should keep it in the very first place? The purpose is to identify. So mostly they are called identifiers, or they can be used somewhere for annotation purpose in a graph.
Like you have drawn a graph and there you want to figure out which record or whose record it is. So, and then when you put a mouse over that, then you come to know that it is about this particular person. So for annotation purpose, for identifying purpose, we have a meta attribute. Okay. Clear?
So you create that attribute. Or
Meta attribute by default, when it sees that text variable, it identifies as meta attribute. Movie name and release date, they are by default recognized as meta attributes because they seem to be like a text, right? Yeah. Now we can make use of them for creating categorical variables. For instance, say the release date, I want to extract the months, or I want to extract the dates, whatever. Right? Months is something which might be interesting because which month most number of releases happened. So suppose that's the query I want to make. So then I can actually extract the months by pattern matching in that. So it's mostly a string operation which we carry out and find out the pattern. Like now in the release date, we have the months in the middle, right? So then we can pluck that months out and then create as a variable. Okay. Otherwise, it is simply used for identification or annotation purpose. Okay. So this is about understanding the different types of variables. Right. Now let's move to the queries. So if you see the queries, let's look at, okay, the other first one is understood by now. How many records are present in the data set? The answer is 149. You got that by seeing the data table, or in the right from the file widget, you could see that. Okay, let's see the next query. You see how many movies got released in each genre, which genre had the highest number of releases, sort the number of releases in each genre in descending order. Now, typically these type of queries are called as exploratory queries, like you are trying to explore the data, typically descriptive statistics that could be also called, right? So these are questions of exploratory. So how many movies got released in each genre, which genre had the highest number of releases? Okay. So now you know that there is one variable called genre, which you have to look at and see the frequency of that, as simple as that. Okay. So you can see this one, the second loop, which it's corresponding to the second query. Okay. So what we are doing is first we are selecting that particular variable which is on focus. So now we can use the select columns. Now select columns widget, you can see there are multiple ways you can use the widget on your worksheet. Okay. For example, you can go to transform and then choose select widgets, select columns widget and drag it and bring it here. Or else the other way around is, let me show you one more way. Suppose I just start a loop, okay, and I drop my mouse. Then you want to search for a widget, that also can be done. And then you can find out which widget you want. You can just type it out and then it will pattern match with the widget name, and so that also is another way you can. So I showed you multiple ways you can. So either you can first drag the widget and place it and then we give a link, or you start with the link and then search for it and then connect it. Clear? So these are the various ways you can do it. So you see, it's not that hard, right? So either you put that or you can go as per your intuition, you can do it. Okay. Now, when we talk about the select columns, if you click on this, now you see there are 4 sections in this. Okay. Like already I made it, But in case when you're doing it for first time, probably most of them would be there in the features list. Okay, if you're doing it. Okay, but now let's say you can always shift which one you want to consider as a feature, which one you want to consider as a target, which one you want to consider as only meta attribute, and which one you don't want to include in your analysis at all. So when you say in the left-hand side as an ignored section, it means that those variables which you are not using in your current analysis, you can separate it out. So it's kind of subsetting your data. Okay, so ignored one is like you are removing those variables which you are not focusing upon. Okay. Whereas features are the ones where you are utilizing those for your analysis. Target is one where you're setting up that for prediction things. So whenever there is any prediction which you want to do, then you set up a target. Right now, I'm not interested in doing any prediction. Okay, so I'm not setting up any target. Now, going by that question, I'm only selecting the yawner. Okay, so the yawner has been selected. The others are still there. Doesn't mean that the others are not there. In the metas, it is there, but it's treated like metas. So it won't be a focus. It will be only for annotation purpose. Okay. If you want to utilize that information, like sometimes what happens, and this is where Orange becomes very much helpful. Okay. Sometimes we don't want to actually use the data for analysis, but you want it to be there, right? As a backup, just to see if I can connect something or to for annotation purpose. So what I suggest is whenever you want something to be there at the back of your mind, okay, I want to have a look at that in the graph or something, then please keep it in metas. So that is the for the annotation purpose. Okay. Even if you are not seriously analyzing them. Okay. So instead of totally ignoring it from the system, then we'll never have an access to that, right? But one good thing in Orange is anytime you want, you can get it back there. So the good part in Orange is that even if you have progressed a lot and then you see, oh, I missed out this detail, then you simply put it back and it will have that propelling effect in your rest of the forward network. And that's the power which no programming language can give. Because otherwise you'll wonder, okay, we have to keep do some changes there or completely my code will change and other things will happen, right? So that worry won't be there. And you simply have to drag that on that list and then it will come. Yes, the entire workflow will be updated. So that is the magic of Orange. Now, since I'm interested in getting the frequency, I'm just using a pivot table feature because now please note that I'm not an expert in Orange, but I've used most of the widgets in Orange. Okay, so I could figure out that this is the only way I could get the frequencies. So use the pivot table feature, which is already there in your transform widget group, or you can simply drag that and then start typing pivot. That also will give you that. So in the pivot table, this is similar to what you usually do in Excel, right? So you can select the rows. Now you can see here, I'm just because it's always in a matrix format. So rows, then same as rows. So it's just actually repeated, though. So it can't understand that that there's only one variable I want. So this is the frequencies which you got here. Yeah. So now you can see, you can answer the question that which movie had lot number, which genre had lot number of releases. You can say comedy is the right. Yeah, sure. Now suppose now I want this data to be taken up. Okay, so what you can do is you can select this. Sorry. Either you can take this to data table. From here, again, take it to data table. Okay, so in the data table, again, you get the counts, right? And you can use Control A or Command A. Because I'm using Mac, is Command A, otherwise Control A. Copy it, right? You selected that in the data table, and then close this. Go for save data. So in save data, you can click on this. Now, typically, this would be checked. Add type annotations to header or autosave when receiving new data. But I would suggest you not to check this out because it will simply add a annotation about description about that. We don't want that. We want the data to be kept. So you can just uncheck this and you can save it as per your requirement. As an Excel file or as per your CSV file, you can save this. Okay, and of course, you can use it in some other software if you want to. Pivot table, no, so I have not tried that out. I generally convert that into data table and do it. So that, okay. No, so that's why if you want that complete data to be there, so just you're just trying to ensure that. Right. So that's how you can save the data as well. Okay. Right. So you have got the basic operations fine. Now, let's move to the, yes. Yeah, you can go for select columns. No, in pivot table, you can just, okay, in the pivot table, you can choose from the list that you can change. No, what I'm saying, if you want to consider that as a feature, now why these are appearing, please note why these are appearing is not because it is considered as a feature, but because you are considered as meta, so it's still available. So in case you have changing your mind in between, like you just said that I want to change, so it's available. But if you put it in ignore section, it will never be available. Okay. Now, coming to the next question. Again, this is again same way, but only thing is now there are two variables. How many movies in each genre got released in different release times? Yeah, sort the number of releases. It can be done, but here, especially when it is a frequency table, this orange is not a suitable one to do it because it doesn't give you all the data in one column. Usually, how you can sort it in orange is like this. Let me first go to the data table which we had. Okay, the first data table which we started with. Now suppose I want to sort, say, the YouTube likes. Okay, sort the records according to the descending order, say. Then you just have to click on that. Then it will do the needful. And suppose you want to get back to the previous order, which you started with, just go for restore original order. Yeah. Yeah, serial numbers also you can sort it. Yeah, if you have serial number, you can sort it that. Otherwise, you can go for restore original order. Okay. Yeah, your save data itself does that. In save data, okay. Now suppose you want to use this one. Suppose YouTube likes, you want to sort it like this, and now you want to keep it in save data. Yeah, you can do that. What you can do is just copy whichever columns you want. Okay, you can copy a column, or you can just say Command A or Control A, select this, close this, and then use save data. So you see, it says, and it gives you the idea also. Selected data is gone. If you see the flow, selected data, and you can sort that whatever sorted format, you can take it there.
Directly by default, we'll say one.
No, because it will only select the data. Now that is the problem if you are taking from data table. Yes, you can. Nothing, you have to just particularly go to data table. Just a minute. Yeah, it's little, but it's possible. 1 minute. Let me just select. I think you can only do column wise. It's little difficult. I think that can be done in Excel later on. Yeah.
It's set the format.
Yeah. You're right. What you can do is, thank you for this. So what can be done is, in case you don't want to do, you want only particular columns to be selected and kept, you can use select columns. Yes. So what you can do is, here you select everything. Here you select everything. Okay. And then go to select columns. Then say, no, you want movie name and only, right? So you can say, you can select this Command A. You selected this. You can drag whole thing here, or you can just click on that arrow mark. It comes there. So it is ignored. Now what you want, only movie name and YouTube likes, right? So put movie name and YouTube likes. Or you can keep it even features also, no problem. Well, movie name won't go to features because it is a text one, right? So, right. So this is how you do this. Right. And then from here, you can save data. It will save it. So now you could do even subsetting. Okay. But that selection is important because otherwise it will not select. Suppose you don't do selection here. Suppose I don't do any selection or only, and now go to select columns. You will not have. Okay. So please do that and then. Okay. So now let me show you some interesting thing about pattern matching, because the third question is self-understood that it's just the same thing, but with another variable. So let me go to the fourth one, the fourth question, which is which month of the year maximum number of movie releases are seen? Okay. So now there is a task here that from the date, I need to extract the month and then do the needful later on. Okay, so which month of the year maximum number of movie releases are seen? Okay, so this is about making a pattern matching, right? Now there is a feature in Orange, a very useful feature called create class. Okay, or create class widget. Now what does a create class widget do? Let's go back to Orange. Say now, please follow this fourth one. So we are getting here in select columns. Okay, now I'm not doing anything because I want to only pluck the month. Okay, so I've just kept everything in the metas because we never know what is required. So I kept it in the metas. Okay. Now create class. You click on this create class. Okay. You see from the column, which column you want to suppose now it gives you the list of those columns from where you can extract a pattern. So all those categorical variables or string variables or text variables are the ones which should be populated here. Now I want to extract the month, right? So you can choose the release date from this. Okay, so I'm using the release date. Okay. Now, okay, I've already done it. We can do it again. Here there are two columns which you need to update. You are very much familiar with the data, how it is. So you could find, okay, if you see in the data table, you see that it has been written Feb in between. Now I want to extract that part. So pattern matching. So Feb, Sep, so all are 3 digits, right? So we now want that to be extracted. Very useful if you are looking at doing any time series analysis. Okay. So in the create class, the substring which you see substring written. So substring is the pattern which you want to use. So those are the being listed there. Okay. So I'm picking up. So you are typing it out. Okay. So let's type it out. Okay. So now you see when nothing is there, it's showing me 149 instances. If you see on the count, but the moment I say Jan, is showing that in that particular column with that pattern, there are 20 instances. There are 20 records of January. Okay. Now you want to create a class. Now what do you mean by create a class here? It is basically creating a categorical variable. Suppose I want to create a new feature or new categorical variable called month. That means it will be added on as a derived attribute. So we generally call this as in technical language derived attribute. So derived attribute means is something which is derived from the other. Like for example, if you have given date of birth, I can calculate age, right? So in the same sense, here from the date of release, I'm trying to get a month of release. So the month of release, so I can name those like how you want to name that category. So now Jan is that I have named it as January. If you want, you can keep it as Jan. So this name section is completely your take. So how you want to. Now, this is also useful later on. You will see while data cleaning as well. Sometimes what happens, people use their own sense of like because not many people are very much disciplined, right? Okay, let me tell you in the HR area. So in HR part, not that I'm saying HR are indisciplined or something, but let's say in the recruitment process, okay, when we want to standardize coding part of it. Okay, this person should be selected or rejected. Okay, generally, very methodical ways to say 1 or 0. Right? Either 1 means in, 0 means out. Okay, but there are some people who want to try something different, right? Even if it is text also, they should write selected, not selected, right? But no, that they'll write something else. Okay, instead of selected, they'll write hired. Okay, and then there's not hired or not selected. So unnecessary, so many combinations come in where there were only 2 possible combinations. Now, such cases can be sorted out here. Later on in, I think, module number 6, I have given an example of that. Okay, I may not be discussing that but then you please have a look at that. So you will understand that those type of data impurities will be there. So they hired, not hired, selected, not selected, all mean the same. Like not selected and not hired is same, but still they are writing, and some people have written 1 and 0 also. Okay, people like me will write 1 and 0. Okay, people who want are verbose, they will write not hired, and they may write some essay also that. Right. So with all these things in place, your data would be impure. Right. So there also you can sort it out based on the pattern. Okay. The moment person has put up not, it is 0. Right. The moment the person has only put hired, then it is 1. So that way you need to figure that out and you can make a variable out of it. Create instance is you can actually create a data. Instance means a record. So you can create a instance of that and say a record there. So I don't have a specific example for that right now. Okay, but create instance means you are creating a record. Okay, but create class is more like a data pre-processing activity. Yes, you can do that. Sampling data, you can do that. So you can actually create. Yes, you can do it.
Let's say we have an admission data.
Hmm.
Let's say the students come from various colleges. If you're talking about one government college, Halengi. Then we created data. Somebody will write government college, Halengi. Somebody may write GOV, Halengi. Some may write Halengi government.
So you can pick up that one particular thing which is required for you to recognize.
Let's say which is very common in all three.
No. Suppose .gov. You know that it's a government organization. Whatever, like government part. .gov.in. So government is involved. So you can just categorize that as government. Just like here, Jan made it January, right? So go government. Then
Correct.
yeah. But you can see that how many instances are there of that kind, then you can generalize it. So you are faster, right? See here, how much I'm typing. I'm just typing the months. So then when you have specific number of categories only, then you have to do that. So if this is written in this way, and you see, okay, most of the instances are there. Now suppose you are only interested in this case, suppose you are only interested in January. Then you can remove that, only do the January and the rest of them are others, you can say. No, that's why you have to be, this is where smartness will come into picture. So geo means, now if you see most of these geo are government, then you just simply put geo, then everything will come in the government. But let's say you are very much specific there, or there are other words or other categories coming with the same name. Okay, say NGO. Again, NGO also is, but NGO is not same as government. Right? So then you have to put N first and then find out all the NGOs first. Okay. So you see, you need to put the pattern in such a way that you can easily distinguish what sort of pattern comes up. So you should not. So sometimes what happens, there can be overlapping patterns. Like I said, governmental, non-governmental. So governmental is there already. So if you put governmental first, what will happen? It will include even non-governmental inside. But I want to differentiate that, right? So then first you put non. Then you figure out, okay, that is non-governmental. Next part, you can put governmental or whatever. Or some key identifiers for that. Okay. So that's where that can be useful for data cleaning. Okay. But sometimes, yes, I also agree that sometimes, and that's where we get really irritated, right? That yeah, but this simplifies it up to some extent. Okay. See, if there are idiots, we cannot deal with them, right? So manage it. But if there are so many people who do different type of mistakes, so we generally try to do standard mistakes can be handled. Right? Standard mistakes can be handled, but there are extraordinary people who do extraordinary mistakes. And those things cannot be handled in a very patterned way.
Maybe using filter option.
Then maybe filter might be the next option we have to use. So that's where also you can make use of orange. All right. Yeah. So this is about the, so now what happens the moment you put this, you give a variable. Okay. You give a variable name also, new variable name. So now I've put as month, if you're on the top. Okay. So this is name which you give. So, and then you can see that it creates a new variable called month. And you can even see the pattern it is matching on. So now you can use this as another variable for your analysis. Right? So like here we wanted to know about which month most of the releases have happened. So I simply keep the month. And now I get the name, number of movies which are released in each month. Right? So if I just go by there from create class, I go to the pivot table because I already created a month there. And you can see this. Okay. All right. Right. Now let's move to the, so it's a very interesting one. So because many a times I'm queried upon how do we handle qualitative data? And on these are certain things which you can handle with, like suppose you are, especially for those who are into research, generally they have a very tough time in identifying what are the abstracts which are related and what are the abstracts which are not related. So then you can use those keywords. You can actually use orange very effectively there. Just say you have got a bibliometric data where you have abstract data, the abstract of each of the articles. So you just simply use that abstract and then see what keyword you wanted and then categorize those abstracts as belonging to this category. I have done that a lot many times. That becomes much easier for you to figure out different literature points, like or different literature concepts which have been dealt in that particular area. So especially categorization of abstracts. Huh? Yeah, you can. A 10 pages document. No. I'm saying for create class feature, you have to use abstract, which is in the CSV format, where this in one particular column, you have all the abstracts being listed. So that's why I said bibliometric data, you can use that. Bibliometric, you can try that out. So somewhere it assists you even in analysis of abstracts in bibliometric analysis. Okay, movie naming because we want to know the releases, right? No. Huh?
You just need the number of releases per month.
Not. Then we have to put a. The movie name is not. I think it doesn't affect. Doesn't affect. Yeah, you are right. Okay. Now. Let's see a little complex query. Which month of the year typically sees most releases of high budget movies? That is movies with budget of 25 crores or more. Now, typically, if you understand through Excel, it is like a filter. Okay. So let's understand how the filter operation is done in Orange. So Orange filter is done using select rows. Okay. So that is the next one. So now that I have already created a month, so I have started with that. So now see one more part in Orange is that you can have as many networks coming from there. So now see in the previous problem, I have created a month, right? And the next query also has month. So I don't have to restart again. So I just pulled out from there. If you see, I just pulled out from there. And now in the select columns, I'm only taking month and budget. Because now I have a query in which month high budget movies were most released, right? And then, and this is where the logic comes into place that, okay, what is first your priority? Here, first you have to decide which budget is more than 25 crores. So for that purpose, you have to put a condition on the records and this select rows, you are saying that budget is at least 25 crores. So in select rows is basically you are placing a condition. Okay, so now it will filter those rows. Even you can see that if you see down, just exactly down, 149 records are still there, but now there are 66 records which are at least 25 crore. So that details come up immediately there. So there are 66 movies which have budget of more than 25 crores and rest of them are less than that. And you can keep adding more conditions if you want to. Okay, so I'm just going to introduce this feature so you can try this out, right? So, and then once this is done, you can take it in the data table. If you want, you can you see 66 instances only are there with high budget movies that is more than 25 crores. You can even check that out. Yeah. And suppose you want to sort it, you can sort it here itself. Okay, so now you get the top movies here. Otherwise, even in the pivot table, what is this for? Yeah, in the pivot table, you can figure this out. That is also possible. Okay. Right. So the idea was to depict how we can do filtering of the records. Now let me go to the last one. Maybe I've taken a lot more time for this, but I understand this is the basic thing which is required, so I can move faster after this. So in the last one, it's about you creating a new quantitative feature. So let's look at the query. So which are the top 10 movies with maximum return on investment? Calculate return on investment as box office collection minus budget divided by budget. Okay. So that means now you are actually creating a new variable called ROI, which is not there in your previous existing data set, right? So yes, so here we have a feature called feature constructor. That is again a widget which is available in the transform section. So now you want to create a new variable called ROI. So I'm using budget and box office collection as the formula involves only budget and box office collection, and rest of them I'm using it in the metas. And then in the feature constructor, if you click on use this feature, now here you can simply write the formula. You can actually pick up the feature which involve suppose I just want to rewrite this. So I'll delete this. I'll delete everything. OK. See, when you say new, it will ask you what type of variable you want and so on, right? So I'm saying numeric. So now it gives me the formula. You can type it here also. Otherwise, you can remove this. Yeah. Suppose I'll remove it completely. Suppose it's complete. Now this is how you get suppose feature constructor. So now I want a quantitative variable. So I'll put numeric. OK. And I want to name this. So I'll write ROI. OK. And then what is the formula? We said box office collection. So I want to use a feature, right? So I use box office collection. I select this. I don't have to type it also. I select box office collection. OK. I'll put a bracket minus. Now I want budget. So I again select the feature budget. Again put a bracket divided by again budget. So you see, you may not do any typing mistakes. You can select that. And then send. Send. Why send? Because it has to be sent to the next one where. So this is the new variable ROI which I have created. And so send. OK. Anytime you can keep on doing updation, you can change. Suppose your formula changes later on, you can change the formula. OK. So feature constructor. Functions also you can use in the function. Just like in Excel, there are various functions. You can use here functions also. You select the function and then it will give you the arguments and then you can use the features. And then. But in this formula, there is no function requirement. So it was just a formula. Now, so once you have done that, and then you can see that the ROI is created. So now I just wanted to, because I didn't want any other data, so I kept it in the ignored section. See, you can always drag and drop the variables here and there. So I just wanted to focus on the movie name and ROI, right? So I just selected the required ones to be displayed. So ROI and movie name. These are the ones which I've kept it. If you want, you can even keep ROI down in the metas, no problem. OK. And then take it to the data table. So I've got only movie name and ROI. And now you want to sort it according to top 10 movies, right? So top 10 movies. So you can just click on this ROI. This is in the ascending order, descending order is this. So the first 10 movies here are the top 10 movies. So you can select them. Okay, you can see how much you have selected down. 10 I have selected, right? And then take it to the data table. So it will come. And then you can save this also in save data option. Okay. So these were actually the basics of how you can use Orange for data pre-processing, data exploration. So, all right. Okay. So with this understanding, now I'm sure that you don't have any problem in creating these widgets and other things, right? Okay, so we'll close this. Save, no problem. I'm also closing this. Let's move to the next one. So the next module is melting and ANOVA. Okay, so I have a separate use case for this. Melting and ANOVA. Okay. Now, most often, and this is where a lot of people get confused, and I had that experience with the students. They generally do not understand the concept of unit of analysis. So unit of analysis is very much important either in teaching or learning or even in research, right? So at what level you are collecting the data and how you want to organize that, how do you want to treat it? Okay. Sometimes, and somewhere down the line, I see Excel as a culprit in this. Excel has misguided people more of it times, especially in statistics, because it has a data analysis tool pack and it calls itself as a data analysis, but actually it's not a statistical analysis tool pack. Right? And that's the reason why many people do make mistakes while using a statistical software or any statistical concept per se. Now, to start with, let me first give you the example where you can make mistake. So this is the data called program.xlx. So now I have a different format, Excel format. And deliberately I chose this. I could have done it in CSV also, but just to highlight that how Excel can be culprit. Okay, so click on this. So you see, this is a data again, something related to HR. You know, this is about training program. Okay, now this is about 4 training programs where there are 20 say 20 employees. They were subjected to training program. Okay, so 20 employees. Remember, please, 20 employees are there. 5 of them went for program A, 5 of them went for program B, 5 of them went for program C, and 5 of them went for program D. Okay. Now, typically, I may ask this question here also. Can you tell me how many records are here and how many columns are there? Yeah, this is the most common answer I get, that there are 4 columns and 5 records. But you see now here, because the way this has been arranged, it looks like we have only 5 records and 4 columns. But in fact, there are only 2 variables and 20 records. Okay. Okay. Good question. 2 variables. Why 2 variables? Anybody? Huh? So, yeah. So program is actually a categorical variable which has 4 categories: A, B, C, and D. Okay. And the other one is say employee ID, for instance. You can take it as employee ID or employee, who is attending that. Okay, so there are 5 employees who have attended program A, 5 employees who have attended program B, and 5 employees attending program C, 5 employees attending program D. So you agree that there are 20 records. Okay, but seemingly here it looks like there are 5 records and each of them have attended all the programs. Right? And this is where Excel misguides you. Because suppose I do an ANOVA analysis to find out. ANOVA basically is a technique where we find out whether each of these programs are, which one is more effective or does it have the same effectiveness. Okay. Now I very well can do the same analysis in Excel by simply taking exactly in this way, using a data analysis tool pack, and I can get the result. Okay, about the effectiveness of which program has been more effective, or is it that all the programs are equally effective? Okay, but statistically this is wrong because this data is in what we call as the wide format. It's a wide format. It's a pivoted format. This is what you get when you put this in a raw data in a pivot table, then you will get like this. Right? So, but this is in a wrong format altogether. So if you want to analyze some statistical and do some statistical analysis, this is not the right format. Especially if you remember, if you are doing analysis with time series, that's what I'm saying. In time series data, suppose sometimes the data would be given as 2017 data, 2018 data, 2019 data, 2020 data in each column, right? Seemingly it looks time series. Seemingly it's actually, but it's not time series. Right. So now how it would be a time series when you have only a column where there is year and then 2017, 18, 19 would be kept there. And then you suppose sales data, whatever is there. Right. So, okay, maybe I'll be bashed for this, but Excel many times misguides people. Okay. So now for this purpose, what we need to do, if you want to use it statistically, you need to convert it into a long format, not wide format, long format. Okay. Right. And that's where this operation called melting comes into picture. So melting means a wide format. It might sound like fat melting, right? Okay. So many people carry out the operations to remove their fat, right? Sometimes I used to also think about it, but right. So melting format. So melting a wide one to a lean one. Okay, a wide one to a tall one or long one. So that operation is called melting. So let's do that. I hope you got the use case. So you can open this melt. This. So in this melt, I have taken up the data exactly as how it was there. You saw that, right? The Excel file exactly as it is. And here you can see that, you see, it is considering, as many of you said, 5 instances and 4 features. Right? Now it's an incorrect thing. It should have been 2 features and 20 instances. Right? So what do? You go to select columns. See, obviously, all of them, you can keep it in features. So program A, program B, program C, program D, all in features. Okay. This is what you have, right? So now go to the melt operation. The melt. So you will get the melt again in the transform section. So transform is basically all those widgets which transform the data. Okay, so you will get it in melt here. Otherwise, you can pull it and then type melt. You'll get that. And in the melt, it shows you like how do you want to recognize. So you can choose the row number by default. Actually, you don't have to do anything. It will be there by default. So don't touch anything. Commit. And then, of course, here the name for the generated features is asking. So now you know. That's why the understanding of statistics becomes important. Like now you know that these are the variables. One is the program which you have attended, and what is the output, the productivity part. So you are writing output as value and item is program. So it does that. So you just name that out. One categorical variable, one quantitative variable. And you can see the data table. So now this is a long format of the wide format. So now it says program A, B, C. So it recognizes this A, B, C, D. So which program they have attended. So you can actually cross check. Want to? Okay. In fact, you see it's showing you the row numbers, how it was sequence, right? That row numbers actually are indicating in your original data which row it was belonging to and so on. Right? And then, of course, suppose now I want to analyze, as I said, which program is more effective. You can use select columns with new ones. You choose program. Okay, now I'm using output in my target. So because now output depends upon, like, because now you are trying to say that output depends upon the program. So, or this is another way of checking which program is more effective. If the output is more, then that program is more effective, right? So I say that output depends on the program. So that is my hypothesis. And this is typically the ANOVA hypothesis. So ANOVA basically does this operation about where we say that the quantitative variable depends upon the qualitative variable, or the average of the quantitative variable depends upon the qualitative variable. Okay, so our hypothesis is that way. Okay. And then see, I removed that row because I'm not interested in using that information. So I removed it conveniently. And then in the box plot, now this is where visualization I'm introducing. The box plot, you can select which the output is the quantitative variable and your group is your program, and you get 4 side-by-side box plots. And by now you can understand which program is more effective. You can see that program C is more effective because it is way beyond the others. The other box plots are overlapping with each other. That means it doesn't make much of a difference if anybody takes up a program between A, B, and D. But if somebody takes up C, okay, then even the worst fellow there has more output than the top fellows of the other programs. These are basically box plot. Box plot identifies, okay, now what is the purpose of a box plot? So box plot basically gives you 5-number summary. The maximum value, the minimum value, the first quartile, the 25th percentile, the median, and the 75th percentile. So it shows you all those things. It's also popularly known as candlestick charts. Okay, box plot, candlestick chart also is the another name for this. Okay. Now, those who are interested in from the statistical point of view, you also get the test of hypothesis here. You can see ANOVA return 6.14, p-value 0.00, and n equal to 20. So some amount of statistics analysis is also provided here along with the visual. Okay. So this is a very, my intention here was to introduce melting operation precisely, and then how you make use of that in comparisons of different programs. So even if you are not from a statistical background, you can still do this comparison very effectively by figuring out the visualization itself. Yeah, there is a save option down there where a save image is there. So any image which is generated here, you can have a save option here. Like no onwards, if you come across any visualization, you can see that there is a save option and you can save it as a PNG or a JPG file like this. Okay. All right. So this is about the melting operation. Huh? Post hoc. Yeah, again, differentiating with some of the statistical softwares. Now, Orange is a data mining tool. So it uncovers, and wherever it is possible, it gives you a little bit of statistics. So do not expect it to give you p-values. So it doesn't do, it's a not statistical software. It allows you to manage your data, and it allows you to do predictive modeling and other things, which we'll see that. Okay. It does do that effectively. So, but if you're asking, okay, should it throw out all the stats, normal test and other things? Sorry, it can't do that. There is a specialized software for that. And probably that is not part of this part because machine learning more of that. But if you want, we can have sometime, maybe another conference where I'm again conducting a pre-conference workshop. I can have it as a for statistics. JASP is another software which I can suggest for that. Yeah, most of the statistical software will have. Okay, right? Okay. So we are done with this. I see. Okay, let me see whether we have 2 minutes. What I can do, let's say. I'm going little back, but anyway, if you're understanding things, that it's worth spending time. Just a minute, sorry. Okay. This. Yeah. So there are 2 minutes are left. So I'm just looking very at 11 o'clock. So I'm just seeing whether I can. Okay, I think I can cover this third part at least. That's should not take much time because now that it is clear, right? Or at least I get started with that. Or third or fourth, because anything which can be done. Okay, this is good. Let me go with fourth one. I'm slightly changing my order. Fourth one is correspondence analysis. Yeah. And it's a very relatable example. So you'll enjoy, and this is a visual analysis again. Now, correspondence analysis is basically a machine learning, unsupervised machine learning technique where you can explore the relationship between categorical variables. Okay. Okay, so that's the reason I am using this. Maybe I'll end it in some amusing note. So, yes. Yeah, just 1 minute.
Sure.
Okay. So if you see this data, that if you just look at this data, where is it here? So you can see task and person, like who takes care of the laundry. Most of the, now there are, I think in this data around 18 family members, like 18 husband and wife couples, sorry, 18 couples were asked this question, 18 or 30, I have to check the count. Okay, so they were asked who takes care of laundry, who takes care of repairs, who takes care of holiday, like, or who is the decision maker for this, right? So that's why you see there are two variables, task and person. Okay. Now we want to make a visual map of this. We want to make a visual map about who is likely to take decisions of this particular task. So that's where the correspondence analysis comes into picture.
Decision maker is the same.
So, but I'll not say decision maker then. Who takes care of it? Okay. Who takes care of it? Decision maker, maybe it is very skewed. I understand that. Right? But anyway. Huh? The interpret, that's why it is machine learning. So now we are coming to the machine learning. Welcome to machine learning. And this is where you can open this file. So you have, of course, I showed you the data. So 1744 instances. So about what who relates to what. Okay. Then, of course, select columns, you have only two things. So there's nothing much to tell that. And you see the correspondence analysis straight off. And you get the visual picture. So it's basically a scatter plot, kind of a scatter plot, where the activity and the person involved, their combinations have been put up. So what you can see is the vicinity in which the tasks are coming with the person. So you can see husband is here. What does he take care of it? Driving, repairs. Mostly the nearness is here. Okay. No, cluster I'll come later. Okay, I'm just coming next later on. Jointly, what are decided? Holidays, finances, insurance probably. Okay, shopping. Yeah. So wife, you see wife, dinner, breakfast, laundry, meal. Tidying dish. Actually, I felt that tidying is misinterpreted. It should have been very close to husband. But anyway, well, but then it is it's suggesting that okay, it's kind of in more closer to wife, or it is joint. So you can see the vicinity, wife and tidying and jointly and tidying, they're almost the same. But of course, it's far off from husband. Maybe I'm not sure which family it is, but yes, we can. This is a single multiple variables. I can show you that also. We can do this, but it is very simple way to analyze and understand categorical variables and their relationship. And it will do the visualization. Machine learning part is it will figure out the vicinity. That is the machine learning part. Okay, we'll take a break. Quick break. Maybe we'll shorten our break, but we can have it. Yeah. Yeah. Because we have got to cover. I didn't expect that it will take that, but I hope it was worth that. You do it.
See, that's it. No, or later. Yeah, that we go 11:40. Using the bell, then everyone is there. So we started at 11:15 again. I'll just make a small announcement.
Ah.
Okay, we have made a WhatsApp group. So all the participants are there in that group. So we'll be sending I'll send you a link for the workshop. So whoever has not registered, please do register. It's from 2 to 3 p.m. All right? You got an email and yeah, the same one. The same one will send it in the WhatsApp. Okay.
Thank you, Karthikeya. It's a very detailed workshop.
Who is this?
Saharini this side.
Oh, thank you, Arun.
Yeah.
Okay. Have everyone assembled? Can we get started? It's started.
Yeah, 12:40. 12:40.
Okay, we'll get started then. Everyone is there, right? So let's move to the, I just started with the fourth, so let's go to the third one, that is the dummy variable regression. Okay. Now, here I have just a simple use case about how do we, again, those who are into regression analysis or statistical analysis, they would have come across this issue of always creating dummy variables for categorical variables. Now, especially for certain analysis like regression, we make use of the binary format of categorical variables so that we understand the interpretation of the results which we get. Okay. Now, I'm aware that most of you are from diverse groups. So I've taken a simple example of a pricing data set where we are talking about the price of a house. What does it depend upon? Okay. So if you just look at the West Roxbury CSV file, okay. Now this is a data file where you see that there are various attributes of a house being given, like whether the tax has been paid, how much tax has been paid, what is the lot square feet of a house, when was it built, what is the gross area, what is the living area, what are the total number of floors and number of rooms, bedrooms. So all these are typically the attributes of a house. Okay. Now, some of the logic we understand that, like for instance, when we say a 2 BHK flat might cost you more, say, cost lesser than a 3 BHK flat, okay, in the same location. Okay. Or a house which is completely new would be costing more than a second-hand house, right? So it can depend on this logic. Okay. Now, my purpose here is to deal with those variables which are categorical in nature. Now, something like this. Now, there is a variable you see here called remodel. Okay. So this remodel is basically indicating whether the house was renovated before or not. So there are actually three categories. None, indicating that it was never renovated. Then recent means it was recently renovated. And old, it was renovated, but some time back. Okay. Now, probably these renovation, when it has happened or it's not happened, or perhaps it might be a recent one. That's the reason it might be costing more. Okay. So these are the features of a house. Now, typically when we do a regression analysis, like for example here, if I say that the total value of the house depends upon whether it was remodeled recently or whether it was remodeled sometime back, or whether it was remodeled never. Okay. Now, you may have your own business logic for this. So perhaps my logic would be that anything which was remodeled recently, if you have to buy a second-hand house, I'm talking about a second-hand house. That means something which someone has already stayed in that. So when it comes to that, typically what we can say is something which is remodeled recently might be priced high compared to something which was remodeled earlier, or something which is not at all remodeled. Okay. So if at all there's no renovation happened, obviously that house should cost less. The total price of that house should be less because it's quite old and nothing renovation happened. So like that. Okay. Now, when we want to say what could be the average price of the house. Okay, now this is my use case. What is the average price of the house which is remodeled recently, which is remodeled sometime back, which is not remodeled at all? Now, if that is my focus, and I want to say that the total value depends upon remodel, so my total value becomes my target variable, whereas the remodel becomes my independent variable. Right? Independent variable, or what we call as feature. Okay. Now, with this logic, now here the idea is this remodel has to be converted into a binary format for a regression relationship. So generally there is a regression equation. For those who are not very familiar with the term regression, we are trying to map the data of dependent variable over the independent variables, where we try to seek a linear relationship between the dependent variable and the independent variable. Okay. Effectively, if I'm only taking these two variables, it is like finding out the average price of the house for different categories. For regression equation, it demands that the independent variable has to be converted into a binary format. So what it means is that since here remodel has three categories, we need to have at least two binary variables. So, and each of these binary variables is like a switch. Okay, think about it as a switch. So if I say remodel old and it is plugged as 1, that means it has been remodeled sometime back. And if it's plugged as with 0, then it is not at all remodeled in the past. Same way, when we say remodeled recent, if it's plugged 1, then we say it is recently been remodeled. If it's 0, it's not been remodeled. So like a switch. Okay. So now because we want to depict these three combinations, we need at least two variables of binary format. And that's what we get it immediately. So usually when somebody tries to do it in Excel, it becomes a little tedious. We start to put a filter and then put 0 and then again 1 and pull 1. So like that, it takes a lot of time. So you can speed this process by simply using this feature available in Orange. Okay, so let's do that. So you can open this dummy variable. Okay, so where I've read the data file, so you can see the data file is read. Okay, I'm interested only in these two variables, let's say, because I can also do with the others, but for timing, my focus is on creating dummy variables. So with that example, with this use case, I'm saying that the total value depends upon the remodel alone. It might have different factors. Okay, don't deny that, but now I want to just explain this part. So total value depends upon remodel. Now, this is the variable which is now categorical variable. As you can see, it's C written there. So it means it's a categorical variable by default. Okay. Now I want to convert it into a binary format with a numerical extension. That means I'm giving a continuity in terms of numbers with 1 and 0. And then I want to have a regression equation. Okay. Now, so I've kept the remodel in the feature list because this is what I want to modify, and total value is my target variable, which I want to relate with. Okay. Now, if I simply make use of the pivot table, I can get this result by, you see here, I can simply, okay, I'll remove the count. Yeah. So you can clearly see if I put remodel in my rows and in the values aggregate, and I take the average of that, I can clearly see here that those houses which were not remodeled at all, the price is 380.18 on an average. And those who were modeled are 405. And those which were recently modeled, they are higher, 446. Right? Okay. Now, how do I get this even in a regression? Let's understand this. So the first thing what I want to do is I want to convert that categorical variable into binary format. And this is where we make use of a feature called continuize. So continuize does the feature of converting a categorical variable into binary variable. Okay, so when you use this, okay, let's click on continuize. You actually don't have to do anything. By default setting would be like this. So just use this. So first, no, but let's understand this part. First value is as base. It's saying first value is base. Now, what do you mean the first value is base? So what it does is in the data set, in that particular column, if it finds out one category value. Okay, so let's have a look at that. I'll close this. Suppose I look at the data set here. So, and if I look at, so it's saying none. None is the first value which it comes across while scanning. So now this none will be taken as a base. That means the other two would be converted into binary. And if there it is 0, 0, it means that it's none. Okay, we'll understand it once we get through the lecture. So in the continuize, when we say first value as base, we'll take that none as the base. Okay. Numeric feature, leave them as they are. Yeah. In the same place we are leaving it. We are not doing any other operation on that. Categorical outcome, leave it as it is. So it doesn't make any thing. So there's no trouble straight away. Use this. And now have a look at the table. Now we can compare. If you go to the revised one now you see instead of, so you can clearly understand that remodel none was taken as the base, right? So it's base, but the left the other two categories, they have been given switches. So remodel equal to old and remodel equal to recent. So they are the binary format. Now you can relate it very well. If you see the first record, which was none, as you saw that, right? Now here we say it is 0, 0. So what it means is it is neither old or neither recent. So it's understood that it is none. But let's take the second record. In second record, it says it is recently remodeled, but not old. Okay. So what does it mean? It is remodeled recent. So you can even have a cross check. If you go back to the original data, you see the remodel second record was recent, right? Okay. So if you go back, come here, you can see that it has accordingly made that plugin. So now you see it's so easy to create dummy variables. Otherwise, you would have struggled to do this binary variable creation in Excel. Okay. Now let's use this in regression. Okay. So what I'm going to do is the continuous one, which we just saw. I'm again taking it to select columns. Now you can see that now we have a refined version. The old version has been left out. Okay. Okay, so remodel old, remodel equal to old, and remodel equal to recent. These would be considered as your features instead of just remodel term. So we have already pre-processed it, and then total value is the target. Okay. Now from here, I'm taking it to the linear regression. So now I'm coming slowly to supervised machine learning technique. Okay. Where supervised machine learning technique refers to that you should have a target variable, then you can do a prediction. So now linear regression. In linear regression, there are different varieties of linear regression. For time being, I'm just using no regularization. That means doesn't. So I'm sparing you with the other details of regression because then I'll be going into far-fetched idea about even teaching that in this course, which is not right. Okay. So now let me go with a model where you can consider this like a linear line equation, right? So y equal to a plus bx kind of thing, right? So where y is here total price and x is the whether it's remodeled or not. Okay. So I'm going with this no regularization feature, okay, which is by default. There are other advanced things here, which I'm sparing you the details. Okay. Now, from here, see, it's done. Already the linear regression is carried out because you have already defined your target variable in select columns, right? And so in the data table, you get the coefficients. So if I just plug it and put it into data table, you get the coefficients here. Okay, now let me just give you an interpretation of this coefficient. So this is like a regression equation. It's a regression equation where we say that the intercept is 380.189. Now, how do you interpret this? You see remodel equal to old and remodel equal to recent are the other variables for which the coefficient is being given 24.8994 and 66.3298 respectively. Now, how do we interpret this? So the intercept value is the average price of the house, which was not at all modeled. Yeah. So if you recall this 380.189, if you remember in the pivot table for none, we had average price as 380.189. Correct? So you just check the pivot table output, you get that, right? Yeah. Now, the other coefficients are what is the additional increment if it is. So what is the value addition of those? So if you are talking about the interpretation in this way, like somebody asks you, like I suppose you are an analyst who is talking about the price. what is the value addition for my price of the house, considering everything else is same, but I just renovate it. Okay, so say if you have renovated earlier, then you may get an additional increment of on an average 24.89. But if you have renovated recently, you get an additional increment of 66.32. Okay, so in turn, what it basically means is that if something which is recently renovated, it would have base price of 380.189 plus 66.32. So 380.189 plus 66.2, that would be the average price of the house which has been remodeled recently. And remodel old would be just an increment of 24.8994 if it is remodeled sometime back, but at least remodeled. Otherwise, if you are not renovated at all, you will get the base price. It is like when you suggest that, okay, I want to sell my car. Okay, sell my used car. How much I will get? Say at true value. They'll say, okay, this is what you get after depreciation. Okay, some depreciation they'll say no, but you'll say that I added some more features in that, so I should be getting more price for that, right? If I'm selling, like I have covered it in such a way that I did all the painting, everything again, so I should get more price. So what is the additional value? That is what we are saying. Okay. Yeah, you can. That's what I'm saying. You can do that. Yeah, but then the the dynamics changes. Right? So we keep one at a time, then we can understand a clarity. Okay. So I actually prepared this for simplicity so that those who are not so much accustomed to linear regression, they can also understand this. Okay. So that is what we are interpreting. So in fact, you get the same idea, same thing in the pivot table also. So if you see the average price of a house which is remodeled recently, it would be 380.189 plus 66, so around 440 something, right? So if you close this and see in the pivot table, you actually get the same thing, 446. Now the regression equation is just giving you the incremental average value, what could have been done if this category was introduced. Right? Yeah. So that is the idea which I wanted to convey. So basically my focus was how to create a dummy variable. We call the binary variable as dummy variable. So that's why, because I've used dummy variable, so it's called dummy variable regression. Okay. Yeah, I'll come to that. Okay. Now in predictions, suppose now I want to use this model back for the predictions things. Of course, here there's nothing much to tell because it's going to give you the average price only. So so predictions, what is done is that this model which you have prepared using this data, you can supply it to some new data also. Like here I've just use the same data again for prediction purpose. You see this from here I'm getting the data, I'm putting it in the predictions. There is a model. Think about something like this. There is a data and a function. So I have prepared a function out of the data. The linear regression is a function which I have prepared out of the data. And now this, so this function or model, I'm applying to a data set and then I'm getting predictions. So in these predictions, you can see that you have what is the actual value and what value you got by the model. You see linear regression, there are some values and there is a total value. So we are trying to say that if you are applying a linear regression model and you are getting these as prediction values and these are actual values. Now see for yourself whether you can apply this model. Does it make sense or not? If you make sense that, okay, kind of giving some idea about the scenario, then you can use this model. Correct. Now here we have, just like, again, those who are familiar also, or those who are not familiar, that's fine. You have some statistics down. If you see that there is a down, there are some statistics which are provided here. Okay. And typically these are available even in any statistical software as well. Like R square. R square basically means how much does the model explain about the phenomena, about the changes in your data. So here it says that it's only 5.8%. That means the telling that the average price of the house depends upon whether it is remodeled or not is only 5.8% explanation is given by this model. So would you like to take it or not? Okay, so sometimes generally we expect it to be at least more than 50%. Even 30% is okay. But I'm saying it really depends upon which model you can rely upon. So more R square value, then it means that it's more reliable model to apply. Okay. So here it is just 5.85 because we are kept only one feature that we are saying that it is dependent only on the remodel thing. But if I place the other things, perhaps I might get a better model. Okay. So like that, there are other statistics here given mean absolute error, MAE, that is nothing but the difference between the predicted value and the actual value, which is shown out here, right? Same way, root mean square error. So these are just different ways of expressing what is the difference between the predicted value and the actual value. Okay. So some of the statistics are available here, but don't expect a p-value here because it's not a statistical software. It just gives you what can be computed and it'll just give you that. But don't ask for p-values and other things. It will not give that. Okay. Right. Yeah. Okay. So this is about dummy variable. Okay. Now let's move to the fifth one. That is the principal component analysis. Okay. Principal component analysis. Now let me give you the prime idea about principal component analysis. Now this is similar to what we did in correspondence analysis. If you saw, there is a in correspondence analysis, we tried to map certain categorical features aligned with some persons, right? So like task and person coming together and so on. Okay. Now here, our idea is that when we have too many quantitative variables, if there are too many quantitative variables, then it becomes difficult to compare. So let me give you a most practical idea is like this. Say you want to do a industry analysis, wherein you're actually doing comparison of companies' performance. So different companies in a particular industry, you want to compare them. Or for that matter, some of you are, like most of you are from the academic thing. Now, if you want to compare students based on their performance. Okay, so generally we end up getting a CGPA, right? CGPA, and then we compare them. Okay, but let's say I want to figure out the basis on which we should compare them. Finding out what is the logic of comparison. Is it only CGPA or is it that, okay, I want to figure out that this much I should give for the weightage. Okay, sometimes we also do that in our admissions process. In admission process, we say that, okay, we want to give certain weightage for experience. We want to give certain weightage for the way they act in the interview. they behave in the interview, right? So probably that might be different criteria we'll give. Okay, we give weightage for some weightage for experience, some weightage for this, some weightage for their CAT score. Like that. So likewise, we want to prepare that criteria based on which variables should be important. And sometimes even students wonder on what basis I got these marks, right? Like start on what does a faculty like in me that I got these marks? So then they start to capitalize on that, right? So now this is where principal component analysis might work out well to summarize certain variables into one. Because if there are too many variables, then it becomes difficult for us to do a comparison. Okay, now the most easily resorted technique would be to take an average. But then sometimes it becomes a very dumb idea to take an average. Because you cannot compare apples and oranges and then you bring it, right? Take an average of the things, okay, on an average. So as there's a common joke, right? So who is a statistician? So the one who keeps, okay, his legs in hot water and a block of ice on their head, they should feel comfortable. No, that's not that, because on an average they should be comfortable, right? Very cold and very hot. But that doesn't work every time, right? Maybe the person might feel comfortable. I don't know. Never tried it. But yeah, so in the same way, here we need to give certain weightages for different, like which variables might be more important, which variables may not be more important. So it's all about trying to understand the relative importance of your quantitative variables. Okay. Now, let's understand the data set here. So I've given a, again, very relatable example because generally we are so health conscious now that we start wondering about our cereals, right? So let's look at this data set of cereals. Okay. Now you see that there are different cereals which are mentioned, and there are different composition of those cereals. Now, how much carbohydrate, how much sugar, how much potassium, how much vitamin. Okay, what we should resist, what we should eat, fiber, right? So these are different things are there. Now, if I want to say that these, what could be the common important criteria of evaluating these? Okay, so generally we say, oh, I'm very much slim conscious, so I should have no sugar, no low fat, less carbohydrate, more protein, right? So then you want to decide on what should be given weightage, right? Should I give more weightage to sugars or should I give more weightage to carbohydrate and so on, right? So then now this is where the data is there. We are trying to reduce this number of criterias because if there are too many criterias, you'll get mad, right? So you want to decide on lesser number of criterias, and that's where we design what we call as principal components, so that we get the juice out of this, right? Like imagine that these are all fruits, just getting a juice out of it, and okay, then figure out which is edible for me to take it up, or comparison, right? Maybe because I'm a foodie, I generally focus on this type of data set more. Okay. So when we say we go to the PCA, okay, so you can open this PCA file. Here the idea is very simple. Our objective is to reduce the number of quantitative variables. Okay, and see, can something which can be explained in two sentences, and this is where I always had an argument that why should a research paper be of 50 pages? Can't it be explained in 5 pages? Right? So in the same way here, if there are so many variables, can't it be reduced to lesser number and then explained? Life would be so easy. Right? So here also we say that when we have so many variables, you see there are 13 variables which I have considered here, like calories, protein, fat, sodium, blah, blah, blah. Obviously, there will be some correlation between them. So now we are going to capitalize the correlation between them and try to reduce this to a compact size which can be compared. Here, I think shelf is more about shelf life.
Okay.
It's not about shelf per se. I think it's shelf life. That's what I understand, but maybe I'm wrong. I interpreted it as shelf life. Okay, so shelf life of that.
Okay, good. 3 days, 4 days.
Yeah. So now we have this data. Thus, okay, now you can see that we cannot just take an average of this. It doesn't make sense because they are in different units, right? So we cannot fit that average concept here. But what we can fit is what is the weightage I should give for each, right? So a weighted average can be considered, and that's what we are going to do. And that is coming from data, and that's why this also technique is also an unsupervised machine learning technique. Okay. Now, again, I'm sparing you the details about how internally it is computed because that's not none of our interest, right? So unless you are doing a research in this itself. So I kept this and I've kept the other data for annotation purpose because later on we'll see how we can make use of this for annotation in the graph, right? And then I introduced this PCA. Now in the PCA, there's some operations we have to do, something like a what if analysis. Okay. Now you have 13 variables. So our objective is that can I size it in such a way that I'm able to understand the concept. It's something like summarization. It's a data summarization. So I want to size it in such a way that I can understand this better rather than getting into huge number of variables. So 13 variables, instead of analyzing 13 variables, can I analyze it 4 variables or 5 variables, which will give me the gist of the whole thing. And here the idea is to capitalize upon the correlation between the variables. So if there is a high correlation, then you can say that, okay, that makes sense to combine them, right? Okay, and this is what we are trying to look at in this. Now we understand here that different variables are measured in different units. So to make it simplistic, we standardize them, or that operation is also called as normalize. So you see there is a normalize operation being carried out here. Now, what is the purpose here for doing a normalize first? To bring everyone to the same platform, right? Yes, it's a Z-score basically. It's a Z-score. So Z-score is basically a standardization where we are just trying to find out how much is a individual value away from the mean, is number of standard deviations away from the mean. So that is what we are doing. So we are kind of removing that benefit of units which one can get. For example, if I say that I gave you 1,000 rupees, so 1,000 rupees, but the same thing if I express in paise, then it becomes a large figure, right? So it would be. So then just because something is expressed in a different unit should not get the benefit of overwhelming some things, right? Sometimes that might create a shadow, and that's why we avoid that to happen, and that's why we use normalization. Now, having said that, now I've brought it to the same platform by getting rid of the units. Okay. And a level playing field. So now here we can just make use of how much, up to what extent I can reduce my 13 variables. Naturally, if there are 13 variables, it will explain 100% of the information. So whenever you are doing any kind of summarization, sometimes the certain information gets lost in the translation. So imagine when you have, that's the reason why people ask for abstract, right? Because when we say that 10-page or 50-page research paper is converted into one paragraph of abstract, a lot of information is lost in the process. So we try to gather the essence of that in the abstract. So that's exactly what we do here also, that when we have so many variables, we come to that particular point where we can say, okay, fine, I got the idea, the bigger picture, if not the complete details. So this is where we try to do this. So if we know, okay, now I've just made it to 4, but you can try this out yourself here. Let's say I reduce the 13 variables to only one variable. No, that does it automatically. And that's where the machine learning comes into picture. Okay. So what it does is, suppose now here I can make a what if analysis to check. What if I reduce those 13 features which I had to only one? Okay, only one. Like 13-page of research paper, I convert it in one research paper. 1-page research paper. Okay, so now you see, if you make it to 1, it makes an attempt to explain 27% of the variance. That means we have lost 73% of the information. Right? So no, that is not a great thing. So just because you want to reduce your work doesn't mean that you have to flatten it. So, okay, so you have to be a little practical, right? So now we see, okay, what if it happens to 2? So now you see, if I reduce from 13 to 2, it explains 52% of the variance. This is pretty okay. 48% is still, but 48% of the information is lost. So generally, a rule of thumb is that at least 70% of the information is retained. Okay, so we make an effort to at least have a parsimony between the number of components we would like to have and what is okay to lose, because it's like a opportunity cost, right? Kind of thing. Like if you are taking up this opportunity, what you have to forego. Okay, so if you want to enjoy a lesser data, number of variables, of course, something you have to sacrifice. But the sacrifice should not be too detrimental for your analysis. So that's where we look at. So this 48% loss seems quite high. So let's take it to 3. With 3, I see that it is 66%. Okay. Now, one thing which you notice is that as I increase the number of components, the additional contribution coming up slowly fades up. So you can see the first one was 27. The additional contribution of the second component would have been just 24% additional, because it becomes 52. So you can see that in the figure itself that 24% is the additional thing. Then if I increase it to 3 component, the additional value addition from the third component is 14%. Right? Because overall it becomes 66, but from 52 to 66, so 14% increment. If I make it 4, again it still reduces to 8%, 66 to 74. Right? So likewise, if you keep on doing 5, it slowly goes 5%, 6%, and then it will end up last components, it will be hardly 1-2% contribution. So you see with 6, it is 87. Okay, but you need to also see how much is the drop. Is it significant enough to consider? So that's why usually a rule of thumb is that go with a maintenance of at least 70% of information retained or other explained variance to be greater than 70%. Now, so now let's say we go with the 4-component solution. That means we decided now that the 13 variables which we originally had, we are reducing it to 4 components. How does it reduce? It is like this. I don't know whether I've sent you that mail. Yesterday, I sent a mail giving directions. Just giving an analogy. Yesterday, I sent a mail to some external participants to how to come here. And probably one may not have noticed it, that I also sent the, I not sent a mails. I given mail IDs of other people also who are traveling. So I expected that in case, if you know the other co-participants, maybe you can come together. Then you will reduce your fare to come here to our venue, right? Some people do that, right? Okay, if they are coming from Udupi railway station to here, okay, both of them, suppose the 2 participants are coming from Udupi railway station to here, then they can come in a single auto and come here, right? So that is cooperation, right? And in our language, we call it as correlation. So that's why I said that when the quantitative variables, we capitalize on the correlation between them. Like, okay, let's go back to the variable. Let's look at the variable. Say calories. Does calorie increase when sugar intake is increased? Yes, right? So that means they go in same hand in hand. More sugar, more calories. Automatically it's like though they are going in the same direction. Why don't we join hands? And I'll save my trouble of analyzing them separately. Sometimes, just as a joke, when it comes to team assignment, when we give some group assignments, right? So in group assignment, the group will give one single assignment. Sometimes we also give individual assignments. And say the student copies the assignment from the other person. Then I always say, if you had to copy only and give it, why give me additional trouble to evaluate the copies, right? You can as well as write name together and say, okay, we submit together. Isn't it? Okay. In fact, I do the other way around. Is when I see that there are multiple copies of the same thing, so I divide the marks among them. Okay. Right. So it's a parity, right? Okay, each one of you contributed to this, so they should be divided. Right. Yeah, I'll come to that. No, not based on correlation, based on similarity. I'll come there. Yeah. So my point is, when you have a flexibility to reduce and analyze and get the same inference, then why take an effort to make it complex and then analyze? Right? Make it simple and analyze, right? So that's the idea which we are going to do this. Okay. So I hope you got the point. So the calories and sugars might go hand in hand. So why take it separately and analyze? We can combine them and say, okay, they are the ones which will add more, like we come across a common theme for that, and then, okay. Now, then, yeah. So the basic idea of principal component is which are the ones which are distinct from others. So the correlation between the principal component is 0. So what we are going to extract, like here when we say that we have got 4 components. So those 4 components, the correlation will be 0. Okay, we don't want to add to duplicacy. Yes, it will show. That's the reason we'll come to that. So is it clear, the part? Okay. Now, to understand which components are belonging to what. So we generally from the PCA, we go to the correlations. So you see from the PCA output, I am taking it to the correlations. In the correlations, you can see this. And this is where things become more interesting. And now we know what should be given more importance. Okay. Here you see, because you have selected 4 components, each one of the 4 components, how much correlation they have with the actual variables, you can see that. So, or rather we can say which original variables contributed towards that particular component. That also can be understood. For example, here, PC1, you see that PC1 with fiber, for instance, the correlation is 0.864. So what does this mean is, now the PC1, PC2, PC3, PC4, they are the newly created variables. They are the newly created variable. In fact, you can, on minute, before I go here, let me show you in the data table. Just a minute. Sorry. Okay, this one I selected on that. If you see after the PCA, if I pull out a data table from here. So what you can see is that there are 4 more variables being created based on your PCA analysis. Okay, that means you can ignore the other original variables are here, but you can ignore those variables. Now you can be mindful of only analyzing these.
It's called as PC1.
So they have been like, that's why I said make a juice out of it. So you take up calories is one fruit, protein is another fruit. There's fat. So you put in a blender, then you get 4 different principal components. Okay, so we're making a juice out of it and then getting it. Okay. So now we have got these 4 things. Now we need to understand what these 4 generally represent. Like we want to get an idea about what is this PC1, what is this PC2, what is this PC3, and so on. So that's where we look at the correlations. So now you can take the Pearson correlation and you can even select PC1. Suppose I want to see which are the ones. So now I see that along with PC1, what is the correlation of each of the original variables? And I can see that fiber is highly correlated. Rating is again highly correlated. That means rating is what's based on healthy rating, health rating is. So any fibrous food is given a high rating. Potassium is high. Okay, so those who are calorie conscious can pay attention here. So fibrous food, protein food. Okay, now calories is negatively correlated. Obviously, because it's a you don't say high calorie food as a high rating food, right? So it's negatively correlated. Then number of cups is negatively correlated. Maybe quantity is less. You have to eat less, but feel full. Okay, with fibrous food. Okay. Even fibrous food I eat a lot, but that's a different thing. But you can consume less of fibrous food. That's what it means. So So again, sugars, you see, is negative. So in a way, you got an idea that PC1 indicates health consciousness. Like if you translate this and absorb that idea that it could be health consciousness, right? Yeah. And now comes the relative importance of the variables. You just saw in PCA that the first component explains 27%. So now it is like this. Think about like this. I generally say this, but nobody should take it personally. Okay. See, there is a very important person. Imagine there is a very important person, say a MLA or MP. Okay. Now, generally we say that the relatives of that MLA or MP may have a additional advantage or more advantage compared to any normal person in getting certain things done and other things. Why? Because they are related to an influential person. Right? Does it make sense? Yeah. So in the same way, if I say here that PC1 explains 27% of the variance, that is the maximum any component can do. So anything which is correlated with them, they automatically become important. They automatically become important, right? Means to say that in this process, we understand, and that deliberately I kept that only. Okay, I again go back to PC1 combination. Okay, if you just choose PC1. So now you can see who are the good allies of PC1. Fiber is a good ally, rating is a good ally, potassium is a good ally. That means they are given more importance. They are given more importance in the data because they are explaining most of the things about the data. So if you are looking at cereals, you are probably looking at, let's suppose you are reading an article on cereals with this, probably you are looking at fiber, rating, potassium, protein. These are the things which you are looking the most for. Right? So this is how you can also find out the relative importance of the variables in the data set. Okay, and thereby give more weightage to that. Okay. Yeah.
From many components to minimal component.
How
did it come that it is 4, 3 or 2? Can you confirm that?
432 means what?
PC1, PC2, PC3, PC4. Now,
The PC1 always, for the first component, always explains maximum variance. Now that is the algorithm itself. The algorithm designs it such a way. No, 4 components our take. We are seeing that it is explaining around 74%. You saw that, right? So we are saying that okay, 4 components are good enough for us to make a judgment, because it is instead of looking at 13 variables, you can look at those 4 variables and then decide. Okay. Now I'm also talking from the HR perspective. Again, and from the HR perspective, probably there might be many things which would be furnished in a resume. Okay. But what is that important for you to take it from that resume? So you can decide, okay, no, they might write that even for that matter in our admission process, most of us who feel, oh, I was a school champion on this, I was school this. No, will you consider that for the admission process? Certainly not, right? You may, if you're too much concerned with sports. Okay. But then you may not give that much importance, rather than you would give more importance to their CAT score, more importance to how they perform in the interview and so on. Right. So that's where we say that certain details are there for details, but not really meant for evaluation. And that's what even we do when we are evaluating papers. Okay, you can see n number of nonsense being written for ANSYS script, right? But then we have to find out, make a sense out of it, and then see how much marks we can give, right? So there might be 4 pages of nonsense, but we have to find out what is the 1 page of essence they have written. And that's where this is the idea which we get from principal component analysis. Okay. Right. So this is all about principal component analysis in a nutshell. Yeah, we can also do visualization here. Okay, and I'll come to the other part of clustering as well in this example. Here, of course, here this doesn't make any sense. I just did it for. I don't think this makes sense at all. Oh, 1 minute. Yeah. Suppose this scatter plot we have, right? So this scatter plot after the PCA. Now suppose I place it. Now some picture idea we can get from this also. Let's say I take up PC1. Oh, sorry. I think somewhere. Oh, I changed it here. Okay, I might have. Yeah, let's take this 4. Yeah. So now. Why it's 3 only? 1 minute. Did I make it 3 or? Oh, okay. So let's take it 4. So you can see that it reflects whatever changes you make, it gets reflected subsequently. Suppose I take up, say, PC1 and not fiber really. Well, let's take some other component PC2. Okay. And in the label, and this is where I said annotation purpose, we can make use of the meta variables. So if I put name in the labels, so now you can see that it gives you a visualization about the different variables, the different records based on these 2 components. So you can see PC2 and PC1. Now in PC1, if you see in the extreme side, what you have? All bran, 100% bran, all bran again. Okay. So it is basically indicating all fibrous foods. Yeah. Whereas PC2, okay, we have not understood PC2. So PC2, for that purpose, we can go to correlations and change it to PC2. Now in PC2, we are talking about something. Okay, now PC2 also is on similar lines. It is talking about negative correlation of weight, negative correlation with calories, negative correlation with sugars. So it's almost on the same lines, but let's take up something else. Yeah. It is not that correlated with fiber, but it is more related with cups. You see? Huh? The rating is slightly higher, but not as compared to what we had in PC1. So it is also a high rated food, relatively high rated food, but it has now the difference is between PC1 and PC2 is in the cups. You see here we need more things for that. Correct? Okay, now let's look at keep that in mind that a PC2 is one where is highly correlated with number of cups. That means we want to eat more of this. Okay. Like sometimes some people have a feeling, right? I should eat healthy food, but at the same time, I should eat more food. Like that is what I feel like most of the time. Okay. So now let's look at the scatter plot. Now you see what is very high on PC2? Puffed rice, puffed wheat, bel puri, bel, right? Puffed rice, puffed wheat. Okay, shredded wheat. Okay, now this you'd like to have more cups. It is also healthy. It is also healthy, but we have it in more quantity. Right? Bel puri, more quantity. Right? So these are highly rated too, but they are not as healthy as what is highly rated on PC1. Like if I have to compare between bran and puffed rice, both are healthy, but we may have to eat more of these, and obviously fiber one is more healthier than puffed. Okay, so if you have to ask about whether I should eat carrot or whether I should eat bel puri, obviously first choice would be carrot because it is highly fibrous.
Item comes in PC1 here and it's just adding up.
Yeah, it is showing you the picture about where is this relative position of based on this particular scale. So you can even immediately make out. And that's where I'll introduce you to the concept of cluster analysis also. So now you see, we have got a visual picture based on the components, correct? But now I can say that these are belonging to one cluster. These can belong to other cluster, right? That's where there is a difference between a cluster analysis and a principal component analysis. So now in principal component analysis, we are getting a picture about how each of these products have been positioned in terms of these components. I hope this is clear. Okay. Now, most often, we generally do not end in principal component analysis as our part of analysis. We do something more to that. So the best addition, what I can have is doing a cluster analysis. So I'm introducing cluster analysis here also a bit. Okay. So when we do cluster analysis, we are basically, after principal component analysis, we are using the principal component scores to do the clusters. So if I go to select columns now, you see in select columns, I'm using the PC1, PC2, PC3, and PC4 for my cluster formation. I'm not now using my original data. I'm only using this principal components. And based on this, I can do some clustering techniques. So I'll just quickly glance through one of these. Say I go for suppose a k-means. A k-means is basically a technique, clustering technique of grouping the records based on the similarity in the features. Okay. And so say I fix it up to 4 categories. And then see in the plot. So I'm looking at the same plot between PC1 and PC2. But now you can see that I have made some colors are there, right? Okay. So I've made 4 clusters. So it is showing you what are closer to each other. They are in having the same color, right? Mostly. So let's see all bran, 100% bran, all fiber. They belong to which cluster? C4. So now you see when you bring your mouse over that, you actually see all the details. And that's where we say that this will be useful for annotation purpose, metas. Right? Hope it's clear. Okay. So this is one simple way to describe cluster analysis, because I'm also mindful about the time. So I'm just looking at cut shorting it, some of the details. Okay. Right. Okay. Of course, there is another clustering technique called the hierarchical clustering technique, where, okay, I use the distances between the records. Okay, distances between the records means that I've used this PC1, PC2, PC3, and PC4 as my thing. So how the records are different from each other. So the distances are, if the distances are more, that means they are more dissimilar. if the distances are less, then they are similar. So based on this, there is a visual called hierarchic dendrogram. So it also helps us in identifying similar records based on your variables. Okay. Now to do this, you have certain parameters here. There are different linkage methods based on which you can decide on. So generally preferred method is the Watts method. Okay. And you can also decide on how many clusters you want. So you can even decide, okay, whether I should go with 3 cluster solution, 4 cluster solution. So then naturally you look at the names and figure out, okay, what does that cluster represent? Right. So all those what if analysis part, maybe if you explore more here, you can understand this graph very well. Basically, it is about how close are the records, and you can do your exploration about how many records do you want to have, or how many clusters do you want to have. Okay. Clear on this? So like you can clearly see here that all brown with extra fiber, 100% brown, they are belonging to one cluster. Then if you are going with a 4 cluster solution, but I can also decide to combine these two, say I want to reduce it to 3, then this becomes combined, then that can become one group. Okay, so depending upon where do you want a categorization to be made, you can decide on the number of clusters. Okay. Yeah. All right. Distance basically means that. Okay. I didn't describe that, right? Okay. Now this, yeah. Now distances. Okay, let's look at this. Now distances. Now typically a hierarchical clustering technique takes up the distances into account between the records. So distances basically means how much each one record is different from the other. If they are not that much different, then they end up getting into one cluster. Okay, so typically there are different distance metrics, okay, called Euclidean distance is there. So there are many there, but typically for quantitative techniques, we use the Euclidean distance. So you can see there are many there. So for different purposes of hierarchical clustering, there are different distance measures used. Okay. Sometimes, for example, let's say we want to understand, and again from the practical point of view, if you want to understand which group of items should be kept together in a shelf of a hypermart, market basket analysis. There in market basket analysis, there's something called shelf design. So there we generally make use of the Jacquard distance to figure out which particular products are purchased together more often, so that they can be kept in the same shelf to give customer convenience. Right. So depending upon the purpose, this distance measure can be changed. Okay, now here our purpose was just to identify similarity between the records of a numerical variables. So we are making use of Euclidean distance. Okay. Now later on you'll see that when I'm now this same principle I'll be using it in combining the images. Okay, I'm coming to that. I'm mindfully skipping some of the sections because it's there for your reference, but you can follow it up easily. So I'm going to that image analytics soon after this. Okay. So what it means is for image analytics, you may have a different distance measure, like cosine measure is generally used for image. Okay. Yeah. Right. Now there is something called even MDS, I had a separate section for that MDS. There is another folder, but here also I can show you the MDS. MDS is multi-dimensional scaling. So this multi-dimensional scaling, again, it is similar to hierarchical clustering, but it is a map similar to correspondence analysis. So if I go with this, you might find out like a scatter plot only what we saw before, but it's a different way of a scatter plot where it tries to combine related items in the object space. So which should be kept together and so on. So like total raisin bran, crispy blend, so they are kept together. So all bran with extra fiber, 100% bran, they are separate. Now this is another way of drawing the scatter plot with principal component analysis, a multi-dimensional scaling. Okay. Yeah, you can color it for your own understanding purpose. So that's you have different colors options you can make use of. So you can put type or C or H type. I don't know what is that C and H type. Rating, but rating is quantitative, right? Yeah, it gives you the rating range. Yeah, that can be heat map kind of thing you get here. So there are different ways you can visualize this. There's a lot to explore in this part. Okay. Right. Okay, so I hope you got the gist of the things, why we are using PCA, why where you can use clustering technique. So. All right. Now the next thing which we will proceed is I did have an separate example for clustering and this. Maybe I can skip a bit right now because of the time constraint. Okay. And move to some unstructured part. Image, I can do it very easily and it's quite fun. So let's do that. Image analytics is more of fun there. So I added some fun element where you can distinguish between a man and a dog. Okay. Right. Let's go to image with the same idea of what we have just understood with clustering. Okay. Okay. Sorry, I think this file should be skipped anyway. Yeah. Now here there are some images. So in the image folder, you'll see some images. So I'll show you the images. Okay, I just kept a very simple example for image analytics. So there are some images of cats, cows, dogs, and man. And man, I kept Ranbir Kapoor and who is this? Huh? Vicky Kaushal. Okay, so now our here objective is to do a clustering of images. So can we have machine understanding who is a cat, who is a dog, or who is a man? And even if there is some similarity, okay, what sort of similarity is there between different animals? Okay. Okay. No, I don't want to get into any controversy by adding some female pictures. That's the reason I avoided it. Okay. Yeah. We never know what hurts anyone. Right. Okay. Oh, sorry. Where did I miss out? I think closed it 1 minute. Okay, so let's now you got the idea, right? So that is the use case here. So let's look at the clustering, and this is using the image analytics, which is available as an add-on. Okay, so as I said, some of them are not available by default. So you have to install that. Now in your systems is installed already as an add-on, but if you are trying to do this again, so you may have to install that. Okay. Right. So let me explain. This is very simple. Now that you have got an idea about hierarchical clustering, so now the same idea, I'm conveying it here in the images. Okay, so the first thing what we do is import the images. So I have kept it in the folder, all the images what I have there. So you just have to import that file out here. Okay. So import images, you can see what folder. So you can just access that folder and place it. Okay. Right. And you can even try out with new images, dumping in there and then trying out. So you can do that. Save some JPG files there. So all sort of images you can try. Then there is something called image embedding, which is available in the image analytics group. So in image analytics group, you get this thing called image embedding. Now this is a Google based algorithm, which has already been implemented and kept here. So what it does is typically those pictures are converted into features. So if you look at image embedding, actually you don't get anything from that. Okay, most of the things even I don't know much, but this is just a neural network. Okay, I think this is a convolutional neural network, if I'm not wrong. So it's there are again different algorithms in this. I not tried out all. I just tried out one, which was default. So I just used it and see. So okay, but you can try different things and see what it will give. Okay. So Google's Inception V3 model trained on ImageNet. Okay, so this is what is the feature which. Okay, now you have the images. Now those images are basically only pixels, right? So but then when you actually look at what data it gets converted into, you will be surprised. It has so many neural network data which will be created based on each of the facets of the picture. So based on, okay, what type of nose they have, what type of eyes they have, everything, right? On back of that, you will see, and you see that there's several data for each of the images. So we had only 9 images. So 9 records, and you get different neural data. You see how much it is created based on that. Yes, it is neural network, machine learning, right? That's why we said this is a course on machine learning. So machine learning, which is done. Yeah. Okay. So we don't know, it is auto created. We really don't know what does N2042 mean or what N2043. Maybe if you do some more experiment, deleting some of these and then again trying out, probably you'll come to know what it was meant for, right? But otherwise, this is a black box. Okay, so how did it get this data? We don't know the formula. Okay, it's a auto learning formula. This is machine learning, right? So it's machine is learning from these images and then creating. You can do. That's what I'm saying. You can do PCA and then try that out. So there are so many possibilities. Okay. Now, my idea was to do a clustering. So now that we have got 9 pictures, I want to cluster it, saying, okay, what does it represent? Does it represent, like I have in mind that, okay, this is these are cats, these are dogs, these are men. Okay, but is the machine also talking the same thoughts or not? So that's what we are trying to see. Okay, and see, I have kept a cat which is 4-legged. Okay, and then the cow which is, say, cat is 2-legged. So 2-legged, 4 only, right? Okay, sorry for that. So 4 legs, but yeah, seemingly it looks like a 2-leg, right? And then we have 4-legged cow, and then there is a 2-legged man. So does it understand legs also in the picture? Don't know. Yeah, that it will figure it out. Okay, neural network. With this, we can even figure out the doppelgangers. Doppelgangers, we say no. Like, for instance, if you want to figure out whether they will put, say, Aishwarya Rai and there was one more lady who was look-alike, or Zareen Khan and Katrina Kaif. Okay, I did try that out. That's the reason I didn't put the images here for the workshop. Okay, I did try out these things. Can doppelgangers be identified? Okay, right. But you can try that out anyway, right? So it's a matter of just getting the images and placing it in that folder. Yes. So again, now you see now here we again you're using the distances. So distances, there we had used Euclidean, remember? So, but for images, this is a distance metric which is used. Okay, because of some formula on this. So we use this. Okay. And then again, I'm doing the hierarchical clustering, and you'll have some interesting observations here. Okay, so this is the observation. Okay. And it's proving one particular statement. Okay. And I'll tell you what, and you might realize by now. Right. So if I make it three clusters, I make it three clusters. If I make it three clusters, we say men are dogs. Okay. Hence proved. Okay. Men are dogs. Okay. Maybe I don't know. So didn't try that out with female actresses. Probably they may look like cat if they're in clustering. Right. So you see this, you can do your clusters based on what choice you want to make. So if you three cluster solution, men are dogs. Okay. If you differentiate between dogs and men, then you want four clusters. Okay. Right. But you can see that now both those cat1, cat2, cat3 are just given the name of the file like that. Just for resemblance purpose, we can figure out that.
Not using that.
No, the name of the file. No.
There was a choice somewhere, I feel, and pick name of the file also.
There was a correct. I did. Yes.
The image name is here only. You can use annotation in image name. So image name, deliberately I gave that the file name is the image name actually. So that's why it's given this. Yeah. So yeah, so pretty much that, and then you can actually look at the images with the clusters being formed. So you can look at the image viewer. In the image viewer, you can even see the pictures with their clusters. Yeah, images in a short thing, and you can see the. So you can give the image and title attribute cluster. So you see the lot of annotations possibilities. Yeah, so this is a higher order understanding of the basic machine learning techniques for unstructured data. Okay. Right. Okay. Can I spare 4 minutes? I can even give you some idea about text analytics, because some of you might be interested in qualitative data analysis. Okay, so I'll give you some idea about that, and you can follow it up with this. Okay, I conveniently have skipped the predictive modeling part because I discussed a bit, but there are some more things to that. So then it will take one more, at least 20 minutes more. So then I don't want to, especially lunch, it is very important. Yeah, 1 minute.
Yeah.
See, Right. So let me show you. Okay. Something on text analytics, slightly interesting for those who are looking from the marketing point of view also, and for those who are looking from thematic analysis point of view also. Okay. So text mining and analytics. Right. Now, let me admit I'm still on a work in progress, but so please do not use this data. I did share it with pure faith. Okay, so this is a work in progress on a research paper. Okay, so this is okay. Now this is a data of some interviews which have been taken up. Okay, with women particularly when they are traveling alone. So what are the risks involved and so on. So if you see in this folder of traveling alone, you see that there are some 14 documents, each document containing the interview. Okay, of course, I did because nowadays you have heard about ChatGPT, right? So my mind works on that direction also, right? So what I did, I refined the interview script further in using ChatGPT, where I said write an essay, and then I pasted the content, and then it refines it nicely, and you will see that refined version of that in these documents. Okay, so none of these you'll find it like an interview structure, but more like a story writing with what happened with that particular person. Okay, so that helps in text analytics. Okay, so that way you can use ChatGPT for getting that nice shape for your interview text. Okay. So 14 are there. Okay. Okay. I delete. Okay, closed it. Is it? Okay. So that is there. Now just like how I kept images, like here you're keeping text. Okay. Now let's go to the text word cloud analysis document. Did I do something? Yeah, it's running. Oh, it's auto running whole thing. Right. So you see, okay, here it has missed out. Okay, if I missed out some link here. Okay, so import documents, you can actually load that documents. So you can load that documents folder in that import documents. See where I kept it. Okay. Now where is it? Little messy here. Okay, 1 minute. Okay. Traveling, no. Yeah, traveling alone. Okay, so I'm just if it's not there, please load that traveling alone. Yeah, now it comes fine. Yeah. Gone off.
It was on UPS.
You can just show it there.
Okay, fine. All right. Sorry, I don't know what happened. All right, so this is the what import documents is there, right? So I put that across. Now, basically what happens, all these documents are compiled together and becomes like a repository or what we call as a corpus. So this is corpus of all the documents which you have put from that folder. And you can even look at the corpus viewer and you can look at each of the documents separately. Huh? Yeah, yes, it's an add-on. So in add-ons, you will get that. In options, when you do that, you will get it. Now, you see each of the documents are there. You can see 14 documents. And if you look at this, you can read through that also. And this is what you can even use it for your abstracts. If you have different abstracts, okay. Sometimes I also realized that we can separate out for literature review. You can separate out different abstracts like this and then read through that. Right. So now in this pre-processed text, basically you can remove the stop words, articles, other things, and there can be even a custom text which you want to remove. So you can actually create a text document. I have kept a text document here for your understanding called custom.txt something. So now I've used that also. That means some keywords which you do not want it to be coming up in your bag of words, which you are collecting. Like some of these might be obvious. Like for instance, here I was analyzing the risks which are happening with women when they are traveling alone. What are the risks? Okay, so risk is a common word, right? So then I don't want to use it again for my analysis. It's understood that there will be risks. So I'll use that as my custom text so that those words can be removed from my analysis. Okay, and articles and other things can be done here. So there is an option here, stop words option, you get that. And you can convert everything to a lowercase so that you don't have that problem of capital letter and other things. So that's about pre-processed text. And from the marketing point of view, if you are interested in finding out the generalized theme, then you can create a word cloud simply by just putting that and it gives you the word cloud. So you can get an idea about what are the risks. Some say there are health risks. Some take that there should be some precautions. Okay, and somewhere rewarding what somewhere Google also is there. Yeah, Google also is there in the risk. In Google, in sense, they want to use it for Google Maps. Okay, so those things are also there. So they have been pretty much there, and you can get the count of these words out here. Okay. And of course, you can even put it in the data table and then find out which words are most frequently coming. So your frequency and word count can become. So experience 22, safety 21. Then correct. So now, so you can go back and forth and then figure out, okay, these words are not important for us, right? So I can adapt, change in the custom text. You can write another list. Okay, right. So that's done. So that is about word cloud from the marketing point of view. People want to like see word cloud, so aesthetic view, right? Now, otherwise, if you're very much serious about thematic analysis, then we actually create something called bag of words. Again, bag of words means that pura all this text will be taken as tokens, and then like we say that jadu ka pitara, no, so, a bag of words. Someone full say rabbit out of the bag. So like that, here we are pulling out words out of the bag. So bag of words. Now this bag of words can be done in multiple ways of analysis. Either you can group those words together using a hierarchical clustering technique, or you can use a topic modeling. Okay, seems to be very popular these days. I've submitted a paper based on this. Hopefully something happens, right? So a topic modeling where you can actually generate. So let me show, because hierarchical clustering you have already seen. So let's look at topic modeling. So in topic modeling, this is somewhat similar to bibliometric analysis in sense that you are making some keywords out of the bag of words, which are frequently coming together. So there is something called latent semantic indexing. So semantic indexing basically means that which words are generally spoken together, right? or in the text, you are finding it coming together. So maybe they are relating more with that. The sentiment analysis is different. Sentiment analysis is like how, whether it is showing positive or negative sentiment. But here it is more about the words coming up. So thematic analysis can be done. Yeah, so like which words are coming together. Suppose I go with, again, here is an exploratory thing. And there are different techniques. I'm showing you latent semantic in it. No, nothing, it's no color. It's just a color like this, simple. There's no color, red, green. No, it's same color. It's just highlighting, nothing else. It's same color, no special thing.
Any experience in and
It's not color. Experience is not red. There's no this. Okay, so you can see that there are some variables which are coming uniquely to that. Like when you see food is coming only in second, but none of the other two food is there. That means something related to food. Food issues. पेट खराब हो गया कुछ भी, food issues. Okay, so food risks are there. And then say health is there in both. Google is coming in third one, which is not there in first two. So now now here, because it's a very subjective part, so you need to look at, okay, and then figure out, okay, Google might be the keyword which is differentiating these from others. So then you have to go back to the text to read that. So, but sometimes this might facilitate. Let's say I'm doing an MDS again, multidimensional scaling here. Okay, with this. Now I'm getting some documents like this. Okay, based on this thematic topic modeling, it is positioning the documents based on their similarity. Okay, now my question is how to read them. So you can say doc 7. Now you can see here doc 7. The moment I place there, you get the snippet of that. Right? So this is doc 7 and say doc 8, doc 6. Now you see these doc 7 and doc 6, they are extreme polarities, right, of y-axis. If this is y-axis, doc 7 and doc 6 are at different place. So now you want to wonder what is differentiating so starkly different between doc 7 and doc 6? Why they have been positioned in extreme time? So this is how I go about it, because that gives me a sense that on what basis these documents might have been figured out, right? And that's where I go for the corpus viewer. Oh, 1 minute. Yeah, sorry. In the MDS, you pick up this. Say I highlight this doc 7. You pick up this and you pick up this. I highlight this. So you see, I've got doc 7 and doc 6. OK, I close this and then go to corpus viewer. I get only doc 6 and doc 7. Now I want to focus on that and find out what is that. So doc 6. So doc 6, I see that traveling alone can be exhilarating experience and other things. Now I also see the score of topics. See, the topic scores are also there. So I see that topic 1 and topic 3 are positive, whereas topic 2 is negative. OK, this was with doc 6. Whereas in doc 7, topic 1 also is positive. That means I don't think there's anything differentiating between doc 6 and doc 7 based on topic 1. But there is some difference between topic 3. Right, because doc 6, it is positive, whereas doc 7, it is negative. So now I go back to the topic 3. What are the keywords which are there? Then I see here, I think this one. So no, I think I might have used the wrong choice of thing. 1 minute. Let me go to MDS. Yeah, I was, I think, doc 11. Oh, sorry. Maybe here I could not find much difference, but I can figure out between doc 11 and doc 4 or doc somewhere here. Yeah, doc 4, doc 4. I remember doc 4 and doc 11. And then go to this. 1 minute. Not selected. Yeah. And then I see here. Yeah. Now this doc 11, you see that topic 2 is 15. Okay. So it's looks like more about food. Yeah, I remember that. Yeah, because I remembered food part. Yeah, so, okay. So she says she prefers meaningful travel over typical tourism and enjoys connecting with people. And she brings her own food or something like that was there in this. Whereas in doc 4, she is ready to try new food. Something like that. So diametrically opposite. So you see topic 2 was -2 for this doc 4, and the doc 11, it is 15.5. So food is the issue which is differentiating these two documents. And then when you look into that, in fact, you can correlate it with the topic modeling, what you have got here. Food, eat. So it is about food issue which has differentiated these two documents. One fellow is trying to try out new food. The other fellow is saying, no, I'll bring my own food. I generally prefer to cook my own food even when I'm traveling, because there are some food issues are there. Right. So this is how you see you can differentiate one document from the other. Like some people like more food, some people. So that way you can generate a lot of themes. So like here, second topic is basically food related. So I understood that. So food is the issue, main issue there. Right. So this is where, so it becomes a little subjective, I understand, but this facilitates a lot when it comes to qualitative data analysis.